This video provides another example on graphing parabolas. So if you watched my previous video, you saw the properties, so I'm not going to list them all out. But when we're graphing a parabola, it's a quadratic equation. The highest power is 2 in the function. And we have certain properties if we have this form that we can determine just based on looking at it. Remember, when we talk about these, A is the leading coefficient, B would be the middle coefficient, and C is the constant term. So the first one we looked at is, which way does the parabola open? All right, so does it open upward or downward? And remember, it's based on the leading coefficient, A. So if A is negative, right, if it's less than 0, it opens downward. If it's greater than 0, it opens upward. So we know that this one opens, we can say, downward. When we say downward, that's because A is less than 0, right? It's a -2, in other words. So if the leading coefficient is negative, it opens downward. That means that I'm going to have a shape, that looks like that as a rough sketch. The second thing we ask ourselves is to determine what we call axis of symmetry. Remember, the axis of symmetry is the imaginary line that runs up and down straight through the middle of the parabola, so it splits it in half. So it's symmetric over it. Remember, it has a specific equation. The equation for the axis of symmetry is x equals -b over 2a. And remember, this is a, b, and c in terms of the coefficients. When I say -b over 2a, for our case, we would have negative 6 is b. So it's -6 over 2 times a, which is -2. So I get -6, which makes that a +6 when you multiply negative times a negative, and then 2 times -2 is -4. So 6 over -4 is equal to a negative. Reducing that, it reduces to 3/2. Now remember, this is an equation for the axis of symmetry, so you need to write x equals -3/2. You can't just say the axis of symmetry is -3/2. It's the equation x equals -3/2. Remember, that's a vertical line through -3/2 on the x-axis. Once you have the axis of symmetry, then we look for the vertex. Remember, the vertex is going to be the highest or lowest point of the parabola. The way you find it is if once you have the x-coordinate from the axis of symmetry, the axis of symmetry goes straight up and down through the middle of it. So the x value is the x-coordinate of the vertex, right? We're looking for that point right there, really. To find the y value, we sub x in to g of x, our function, to get the y value that goes with it. So we're really looking for g of -3/2. And that means we're substituting into our original function. So we have -2 times -3/2, the quantity squared, minus 6 times -3/2 plus 4. Then we'll simplify this. Make sure you follow your order of operations. We have -2 times -3/2 squared. The negative squared will make it positive. 3 squared is 9 over 2 squared, which is 4. So -2 times 9/4. Here we have a negative times a negative, which is going to make this a positive. 6 times 3 divided by 2. Well, 6 times 3 is 18 divided by 2. It makes it positive 9, and then plus 4. And simplifying here, this will be -2 times 9 divided by 4. -2 times 9 is -18 over 4, plus 9 plus 4 I can add together is 13. Simplifying -18 over 4, that reduces by 2 in the numerator and denominator to give me -9/2 plus 13. And now at this point, you want to get a common denominator, right? Because 13 is really over 1. Take a common denominator, this should both be over 2. So -9/2 plus 1 times 2 gives me 2 in the denominator. So 13 times 2 is 26 in the numerator. -9/2 plus 26/2. -9 plus 26 is 17 over 2. So that's the y value. So the vertex itself, right, is an ordered pair. It's the point that's either the highest or lowest point in the parabola. In our case, since it opens downward, it's the highest point, and that's going to be -3/2, comma 17/2. Right, so it's a point on our graph. And if you wanted to, just so you get an idea of where it would fall, you could do, if I took -3 divided by 2. In this case, it comes out nicely. I could write this as -1.5 just as our own approximation for the x value. For the y value, 17 divided by 2 is 8.5. So it's really saying the point -1.5, 8.5 is on our graph. So if I was thinking about what the sketch would look like, where would the vertex fall? Well, you know, x being equal to negative 3 halves is the x symmetry, so negative 3 halves is like negative 1.5, so here's negative 1.5. We'll assume all of these are 1 apart. So negative 1.5 would be at negative 1.5, right? And this dotted line here is just representing the x symmetry. Our vertex would be negative 3 halves, 17 halves, so it's negative 1.5 and then up to 8.5. Well, this is 1, 2, 3, 4, 5, 6, 7, 8. 9 would be here, 0.5 would be there, so that's my vertex. I'll label it with a V. Since I know it's opening downward, right, and you know it opens downward from what we mentioned above, we know that this will have two x-intercepts here. It's going to cross the x-axis in two spots. So that's important to know, because the next thing we look for is our intercepts. And for the x-intercepts, how do you find those? All right, so the x-intercepts mean you set y equal to 0, remember? All right, so you set y equal to 0. In other words, you set your equation equal to 0. So we're going to have 0 equals negative 2 x squared minus 6x plus 4, right? What we're really setting is the g of x side. This side is your y is equal to 0. We're going to solve for x, trying to find the x-intercepts. Now to solve this, you might try factoring. That's the easiest way if you can factor it. We're going to factor out a negative 2. If I factor out a negative 2, I'm left with x squared. And negative 6x factoring out the negative 2 is a positive 3x. And 4 factoring out the negative 2 would be a negative 2. And then if this factors further, you want to factor further. Well, does this factor further? Looking in here. Because remember, if we can solve this by factoring, it's easier. It looks like it might factor further. I would need numbers that multiply to a negative 2 and also add to 3. Multiplying to a negative 2 means the signs have to be opposite, though. One's positive, one's negative. So you either have 1 and negative 2 or negative 1 and positive 2. Either way, they're not going to add to a positive 3. So this does not factor nicely. If it did factor nicely, you would solve it how you normally would by factoring. Take each factor, set it equal to 0, and solve for x. Here, though, since it doesn't factor nicely, we know other ways to solve this. I'm going to use the quadratic formula. Or you could also use complete the square. I'm using the quadratic formula on the inside of this. You could use it on this original equation here, but I'm going to use it here because the numbers are smaller. I'm not going to write out all the pieces, but remember x is equal to negative b, so this will be negative 3 plus or minus the square root of b squared, so it's 3 squared minus 4 times a, which is 1. Make sure you're using the correct equation here. So negative 4 times a, which is 1, times c, which is negative 2, all over 2 times a, which is 1 here. Remember, I'm using the inside of this. If you use this, you'll get the same answer in the end. It's just a matter of being accurate with it. So simplifying this, I end up with negative 3 plus or minus the square root of 3 squared is 9. A negative times a negative makes us plus 4 times 2 times 1, which is going to be 8. So 9 plus 8 over 2 times 1, which is 2. So this equals negative 3 plus or minus square root of 17 divided by 2. Remember, these are x values, and this is two answers, right? So this is the x value where it crosses the x-axis, right? The x-intercept, when we set y equal to 0, this is where it crosses the x-axis. So the x-intercepts are negative 3 plus the square root of 17 over 2, comma 0, right? The x value is this, the y value is 0, always for the x-intercept. And for hold on, it's out of focus here. And for the second x-intercept, right, it's going to be negative 3 minus the square root of 17 over 2, right, all over 2, comma 0. Again, it's an x-intercept, so the y value is 0. It's where it crosses the x-axis. Now, that's fine and good, but it might not be obvious to you where these fall on, you know, our grid that we're normally graphing with. So you might want to approximate these, and you can approximate it just on the calculator. So if I said we had negative 3 plus the square root of 17, all right, and then divide that by 2. All right, this is approximately 0.56, comma 0. Now, when you go to answer the question, these are the x-intercepts. These are the exact values, but this is going to help us just figure out where they fall on the graph. So the exact values is what you want. The approximations are here so we know where they fall on the graph. We can do the same thing here, negative 3 minus the square root of 17. Make sure you do that first. Hit enter and then divide that number by 2. and I get this is approximately at negative 3.56 comma 0, right? So the y value is still 0 here. So if I wanted to plot these intercepts on my graph, all right, it's easier to look at these as decimals and put them on the graph. So 0.56 comma 0, well 0.56, that's, you know, like 0.5 is halfway between 0 and 1, so it'd be about there. All right, that's one of my x-intercepts. And the other one is at negative 3.56 comma 0. Well, negative 1, 2, negative 3.56 will be between negative 3 and negative 4, so it'll be there. So we know that we have those on the axis at that point. Those are the x-intercepts. To find the y-intercept, all right, the y-intercept, what do we do? Well, we set x equal to 0. So the y-intercept, we set x equal to 0. Now remember, the original function we had was right here, g of x equals negative 2x squared minus 6x plus 4. So we're really saying, okay, we want g of 0. Well, what happens there? If I take g of 0, x squared, that's going to be 0 for the x, that's going to be a 0 for the x. So these terms are going to cancel, right? It's really going to be just equal to 0 minus 0 plus 4, so it's going to equal 4. Now I'm not showing the work for it. You should be able to do this fairly quickly without showing the work as well, because when you sub in x equals 0, these will automatically cancel to 0, so you're just left with a positive 4. So 0 comma 4 is the y-intercept. So if I was to plot that, 0 comma 4, 0, 1, 2, 3, 4, remember the y-intercept means it's on the y-axis. And then, since we have the axis of symmetry here, you know, you're about 1.5 away here, right? X equals negative 3/2, so it's 1.5 this way. You want to be 1.5 this way, so we want to be symmetric. And then your last step here, step 6, would be to graph this, which we did kind of all the pieces along the way. So all you really need to do at this point is draw your parabola, and you know, it's a curve, it should be curved, going through your points, arrows on the ends because those go on forever. And that's the graph for our function g of x equals negative 2x squared minus 6x plus 4. So I just wanted to show you one more example, one where you actually had to use the quadratic formula to find the intercepts. But remember, at this step here, when you're trying to find the x-intercepts, if this factors nicely, you should solve it by factoring. It's a lot easier. But if it doesn't solve by factoring, you could go through and solve this using quadratic formula like we did. Now, if there were no x-intercepts, which you've seen in a previous example, what would happen here is when you tried to find this, if you didn't recognize it from just, you know, the way the graph was drawn, you could see this would have come out to a negative under the radical. If you had an imaginary solution or a complex answer here, right, if you had a negative under the radical at the end of this, you would have known that you had imaginary solutions for the x-intercepts, which means there are no x-intercepts. So just keeping that in mind as well. But you could check it visually, right? We knew there was going to be intercepts because we had the vertex above the axis and it was opening down. But if it was opening upward and the vertex was there, we would have no x-intercepts. And you could just say that. So hopefully this example helped just show you another way to graph these parabolas. You know, it's going to be important throughout your mathematical career.